Hello there, you're welcome. In this video, we're going to be solving this question which says k raised to power 3 is equal to 27/8. So we want to find the values of k. Now, don't just start off by saying, oh, this is going to be very easy to do, and you decide to take the cube root of both sides. You do this, and then you do this. Then you say the cube root cancels the cube, and then you go ahead to say k is equal to the cube root of 27 is 3 and the cube root of 8 is 2, and you simply say the value of k is 3/2. But this is not the correct way to solve this question. What you just found now is just the real root, but there are other non-real roots. So this is the proper way of solving this question. Let's do it together. So first off, I am going to write 27 and 8 as a power of 3 and 2 respectively. So this is what I'm going to do. K raised to power 3 is equal to 27 will be written as 3 raised to power 3 because 3 times 3 times 3 is what? 27. And I just wrote this in index form, hence I have this. Okay, so what about 8? 8 can be written as what? 2 raised to power 3 because 2 times 2 times 2 is what? 8. And I've written it again in index form, hence I have this. Now, do you know that I can write 3 raised to power 3 over 2 raised to power 3 as 3/2 all raised to the power of 3? Sure, I can, because this 3 can be distributed to 3 and 2 because of the bracket. The bracket tells you that the power should be applied to every number in the bracket. So we're going to write it here. It's going to be what? 3/2 all raised to the power of what? 3. The next thing I'll do is to move what I have on the right hand side to the left hand side. So I'm going to have k raised to power 3 minus 3/2 all raised to power 3 is equal to what? 0. Now, from one of the algebraic identities, when you have a cubic expression like this and you want to factorize it, for example, say you have a raised to power 3 minus b raised to power 3, this can be written as a minus b in bracket, and then what? A squared plus ab plus b squared. This is how to factorize cubic expressions of this form. We're going to apply it to this expression here we have on the left hand side. So let's rewrite this like so. It's going to be what? K minus 3/2 and then what? K squared plus, you know, we had ab here. So you multiply k and 3/2, which will be what? 3k/2. Yes, I can write it like that. Then plus 3/2 all squared. Everything is equal to what? 0. And then with a bracket like so. So let's simplify this expression just one more step. So I have k minus 3/2 in bracket, and then what? K squared plus 3k/2 plus, if you apply square to 3/2, you get what? 9/4. So let's write 9/4, and all is equal to what? 0. Okay, now from 0 product rule, since I have the product of these two expressions equal to 0, it means that either this first factor is equal to 0, or this is equal to 0, or both of them are equal to 0. So I'm going to write k minus 3/2 is equal to 0, or k squared plus 3k/2 plus 9/4 is equal to 0. Hope you are with me here. Now let's solve this first equation. If you move minus 3/2, if you transpose it to the right hand side, I'm going to have k, which is equal to what? 3/2. Now we have one value of k, 3/2, but we're going to have others from this quadratic equation. Okay, now how do I solve this equation? First of all, I need to clear off the fraction. I do not want a fraction. So the thing I will do here is to multiply through by the LCM of the denominator. So I have 2, I have 4. What's the LCM of 2 and 4? It is 4. So I'll multiply every single term by 4. So I'm going to have 4k squared plus 4 times 3k/2. Remember, we're multiplying every single term by 4. Then plus what? 4 times 9/4, then is equal to 0 times 4. Now if you simplify this, 2 will go into 4, 2 times 4 will cancel 4. Then we have 4k squared plus 2 times 3k is 6k plus 9. Okay, and this is equal to 0 times 4 obviously is what? 0. So we have a quadratic equation without the fraction. It's going to be very easy for us to solve this quadratic equation. Now I'm going to use the formula method to solve this equation. If you compare this with the general form of a quadratic equation, which is ax squared plus bx plus c is equal to 0. A is the coefficient of the leading term, so that's 4. B is what? The coefficient of the middle term, which is 6. And c is the constant term, which is what? 9. So a is 4, b is 6, and c is 9. So let's plug this into the quadratic formula, which is what? K is equal to minus b plus or minus the square root of what? B squared minus 4ac all over 2a. So moving on, I'm going to have what? K is equal to, what is b? B is 6. So that's negative 6 plus or minus the square root of b squared, which is 6 squared minus 4ac. A is 4 and c is 9. So times 4 times 9 all over 2a. What is a? A is 4. So take it a step further. K will be equal to what? Minus 6 plus or minus the square root of 6 squared is 36. 4 times 4 is 16. 16 times 9 is what? This is 54. You write 4. 9 times 1 is 9 plus 5 is 14. So 144 all over what? 2 times 4 is 8. Okay, now I'm going to have k, which is equal to minus 6 plus or minus the square root of, what is 36 minus 144? That will be what? Minus 108, all divided by what? By 8. As you can see, we have a complex number here. The square root of a negative number will give us a complex result. Do you know that I is an imaginary unit of a complex number, which is equal to the square root of what? Negative 1. So I can rewrite minus 108 as negative 1 times 108 because I want to bring in the imaginary unit I. So this is going to be what? Negative 6 plus or minus. I can rewrite negative 108 like this. 1 minus 1 times what? 108. Okay. All divided by what? 8. So let's take it a step further. K will be equal to negative 8 plus or minus. I can rewrite this as the square root of negative 1 times the square root of 108. I want to break it down to two numbers. One will be a perfect square, the other will not. So 108 is equal to what? 36 times 3. Because if you multiply these two numbers, you get 108. Okay? So I'm going to write 36 times root what? 33. All divided by what? 8. Now, I'm going to write k, which is equal to minus 6 plus or minus. This is I. Remember, this square root of negative 1 is represented with I, which is the imaginary unit of a complex number. So times the square root of 36 is 6. Then I'm going to rewrite root 3. All divided by what? 8. Okay. So this can be written as k is equal to negative 6 plus or minus 6 root 3 I. Remember, this is being divided by 8. So I can write it like this. Divided by 8 here and divided by 8 here. So if you break this down, 2 here is 3. 2 here is 4. 2 here is 3. 2 here is 4. What do we have? We have that k is equal to negative 3 over 4 plus or minus 3 root 3I over 4. And I can write this as k is equal to negative 3 over 4 plus 3 root 3I over 4. That's one of the values of k. The other value of k is what? Negative 3 over 4 minus, remember it's from plus or minus. So minus now 3 root 3I over 4. And the last one, which was the first one we got, is what? 3 over 2. So this right here is the real solution, while these two are the word complex solution. So you can see now that there are three values that satisfy the equation. I hope you do like this video. Kindly share to your friends and family and follow this channel for more content like this. I'll see you in the next one. It's bye for now.